In this video, we're going to go through the basic programming steps to program the Park Industries Titan. We will be following the basic programming steps that we use in our Titan class at Park Industries. This can be downloaded from the self-help section on our website at parkindustries.com. The first step in this procedure is to create good, clean geometry for programming. These steps may include inserting and placing sinks, adding offsets and fillets, creating seams, and separating the parts. All of these procedures can be found in our video library at parkindustries.com. Our objective is to create finished size parts to be cut. We can also add labels by going to the Titan tab. If all the commands are grayed out, choose Machine Profile Select and check the box next to the Titan that you're programming. And now you can choose Add Labels. I'll start with adding labels to the seams by choosing the Seam button and then selecting the edges of the seams as prompted on the command line. And then right-click to finish, so we can select another button. In this case, I'll choose Wall, and I'll select all the edges to apply the label Wall to, and then right-click when finished. To label the profiled edges, first select a name from the drop-down. If your desired name isn't in the list, you can add it by choosing the button Add Profile. I'll choose the name Pencil Edge by selecting it, and when I see it's active, then I'll choose the Profile button, so I can select the edges to be labeled as prompted below. Then right-click to finish, so we can close out of the labeling window. Step 2 is to offset the outer perimeter of each geometry to 3/16 or 0.188. So I'll choose Offset, and I'll change the distance to 0.188, and then I'll select to offset all of the joined geometry before I click OK. Offset the outer perimeters to the outside, as these will represent the material blanks that were cut on the saw or the saw jet. And only offset the sink to the inside if you are planning to use these geometries to program the saw or the saw jet. For this example, I will offset the sink, so the program I create with my saw or saw jet will cut the sink out as well. And step 3 is to save all these geometries to make that program, which I'll do by going to the Home tab and choosing Save Selected. As prompted, I'll select only the geometries that I intend to cut on my saw or saw jet, which are the ones that I just offset, including the sink that was offset to the inside. And when I finish, I'll be able to choose a location and a name to save this file as. I'm going to use the original location and the original name, but I'm going to add an SJ at the end of it so I know this file is to program my Saberjet. I'll also use the outside perimeter offsets to create material blanks in simulation, but I won't use the inner offset for the sink, so I'll delete it as instructed on step 4. Now I can mirror all my parts to the left of the 0 location as directed in step 5. I'll choose Mirror, and then I'll select all my parts, blanks, and text to be mirrored over. And when I finish, I'm asked for the first point of a mirror line, which I'll choose a location to the left of the X0. And before I pick the second point as prompted, I'm going to turn on Ortho by pressing the F3 key on my keyboard. Now I can pull my cursor straight up to pick a point directly above the first one. Then we're asked if we'd like to keep the original geometries, to which we'll choose No. We only want the mirrored copies. I'll press my F3 key again to turn off ortho, and then right-click to finish mirror. Now we have all the mirrored copies that are to the left of the 0 location and are still all aligned. We can also fix all the labels if needed by choosing Move, selecting the text, and moving it back to the interior of the part. The yellow text can be moved like any other geometry, but it won't be selected while cutting or applying toolpaths. It's also recommended to leave a note that this was already mirrored so you don't mirror it twice. I'm going to create and place the word mirrored using the Add Labels feature from my Titan tab. This can easily be done with the Other button. First, we'll have to see if mirrored is in our drop-down selection, which it's not, so then we can choose to add by choosing the Add Other button. And when we type in the word mirrored and enter, it will always be available from the drop-down selection. And we can use it by having it active, choosing the Other button, and then picking a point to place it. And right-click to finish, and close out of the window. This drawing is being prepared to be programmed for the Titan. So the next step is to save a copy of it as the Titan working drawing. So we'll go to the File tab, choose Save As, and then I'm just going to add the name Titan to the original name, Betty's Kitchen. So you'll end up with 3 different files in your program folder if you're programming a saw. I have Betty's Kitchen SJ to program the Saberjet, and then Betty's Kitchen Titan to program the Titan. This could be a good time to program the saw or sawjet since we just finished saving the prepared Titan drawing. We are going to continue programming the Titan. Step 7 is to verify or move the parts away from each other, which we already have done. The next step, number 8, is to set the materials by going to the 3D tab and choosing Set Materials. And when asked to pick geometry or solid, we'll pick only the outside that we offset to become the material blank. And after we select one, then Finish. We only do one at a time. I'll be working with 3cm in this tutorial, so I'll set the material top to 1.2. The material bottom should be left at 0. The XY stock should be left at 0. The material type is defaulted to main because this is the first material that we've selected. And make sure Delete Original Geometry is checked before clicking OK. And we should notice that the material blank has changed to a gray color from its original green geometry color. And we'll repeat this process with the other 2 material blanks, selecting the very outside perimeter and verifying all the settings. You'll notice that the material type has switched from main to additional, which is correct. Do not set the sink as a material, only the outside perimeters. And this third part, all the settings are correct, and it's an additional material as well. And as normal, right-click to finish. Step number 9 is to turn off the material layer in the Project Manager panel. If your Project Manager gets turned off, like mine, it's very easy to turn back on again. It's normally positioned in this part of your display. The steps to turn it back on are written in the first paragraph in your Programming Basic Steps. Go to the View tab, then Show Project Manager. The panels you will need include Layer, Operation, Machining Style, and Simulation. 3 of the 4 panels overlaid each other with tab viewability, which gives us the most space in our drawing window. If you'd like to get a panel pulled in as a tab with the rest. Click and hold down on its title bar and then drag it to the top left corner of the other title bar and release it. If you were successful, you'll see it added to the other tabs. So we can view any of the 4 panels by clicking on its corresponding tab. Now that we're viewing the Layers panel, we can go to User Layers and then uncheck the box next to Material to turn it off. This allows us to easier select the geometry at the endpoints of common cut edges so they are isolated from each other. I'll use the break command to do this, which is on the Edit tab. And we'll set break geometries and the method individual. When I click OK and am asked to pick breakpoint on geometry, I'll first separate out this seam by putting a breakpoint at each end of it, by picking each end using my endpoint snap. And I can see that I was successful because now each end of the seam has a white X on it representing the breakpoint. Next, I need a tool to cut both edges of this wall, so I'll want to put a breakpoint at this end, still leaving the 2 walls joined together when I put my breakpoint at this end. There's already a breakpoint at this end of the seam, so I don't need to add one, and this front edge is already separated out as well. So I'll continue and add a breakpoint at this end of the seam and at this end of the wall, and I'll leave these 2 pencil edges with the fillet corner joined together so that all the tools will cut them in one pass. On this part, I'll separate out this seam by putting a breakpoint here. And if I put a breakpoint here, it'll separate the pencil edge from the wall. And we'll polish the entire perimeter of the sink so we won't break it into segments. Step 11 is to turn the material layer back on by checking it in the Project Manager. Step 12 is to save our progress by going to File, Save, and choosing Yes to overwrite. Step 13 is to set tool directions on all geometries that we're going to cut. We'll go to the Machine tab and choose Tool Direction to open the window. Here we have 3 sections, one for open geometry, one for closed geometry, and then to set the start point on closed geometry. We'll start by selecting the settings for open geometries. All of the edges in this drawing are open geometries. The only closed geometry is the sink. So we'll choose Reverse and Left, and then make sure No is set at the bottom. Now we can select each geometry to apply these settings to. I'll start by selecting this seam. When I click on it, I see an arrow. And this arrow is to the left of the green geometry line that I selected. Next, I'll select this wall, and the arrow is displayed to the left side of the geometry, which appears to be to the outside, which we would need. That means when we apply tools to this edge, they'll stay to the left and follow to the end of the join geometry. We'll continue to apply all these settings to all of the open geometries, verifying that the arrow is on the correct side. We can change the side of the arrow simply by clicking on the geometry again to reverse the direction as we have set in our window. The sink is a closed geometry, so we'll have to set our window accordingly. On inside cuts, like sinks, we'll set the side to inside and the direction to counterclockwise. And in the start point area, we'll select Manual. And now we're asked on the command line to pick a start point on the geometry. A start point will be the location where the tools lead in and out. Normally, I like to pick the longest edge on a sink. However, I don't want to add extra pressure to this thin front edge. So I'll pick this side instead by placing my crosshairs towards the middle of this line and clicking. So the tool will lead in about here, go all the way around the sink, and lead out at the same location. And now that each piece of joined geometry has a tool direction arrow applied, we can close out of our tool direction window, which does turn off the visibility of the arrows. But those attributes are still applied. And if you want to see them or verify, you can turn on ghost tools to visibly see that they're still there. And I'll click on the icon again to turn them back off. In step 14, we're going to verify and or move all the parts to the left of the 0 location to make room for the Titan table template, which we've already accomplished when we mirrored. All the parts are already to the left. So we can perform step 15, which is to insert the table template, which we'll find on our Titan tab. Step 16 is to rotate and or move all the parts onto the table. This can be done with regular AlphaCam move, but I'm going to use my Move Parts function from my Titan tab. When I'm prompted to select part to move, I'm going to carefully select it by its outermost closed perimeter. In this case, the material layer. And everything enclosed with it will also move to the point that I click to set it down. There's also a Rotate Parts Easy button that works very similar. When prompted to select the part, again, select the very outmost closed perimeter, and then type in the degree to rotate and enter. Now I'll move the other two parts into position on the table. I'm taking into consideration the size of the tools that I'm using and the lengths of their perspective lead in and outs, leaving enough spacing in between each part and to the inside of the working envelope. I'll delete this unneeded text so I can zoom all for step 17, which is to use Save Selected to save any parts in this job which may not have fit on the table. Since all of our parts fit, we'll move on to step 18 and move vacuum pods into place. In this default template, the pods that are enclosed in the green rectangle are the pods provided by Park in their vacuum pod package. I'll use mostly the large one for this example, so I'll copy a few of them into position, setting them safely inside so they can't collide with the tool. And I'll set a copy down over here so I can rotate it 90 degrees to fit the other parts. So like before, I can copy these pods into position on the other parts. Space the pod to firmly support the type of material that you are cutting. And I'm going to add more pods to support the sink rails. So like before, I'll copy it and carefully place it between the two edges. Be aware of the size of the tooling so that you are sure the tool and the pod will not collide. And then we can finish step 18 by deleting any pods that we didn't use. Next, in step 19, we're going to apply styles. And we're going to apply them in the suggested order shown. To do so, we'll go to the Machining Styles tab in our Project Manager. You may have to open your styles folder, or any other subfolders if they were created depending on where your styles were saved. Your styles will be different than mine. You must know what each style does and to what edge it should be applied. Follow the suggested order while applying the styles. We'll be able to skip a few of them because our material blanks were cut on our saw jet, including the sink cutout. So the first style that we'll apply is the wall scribe. By right-clicking on it and choosing Apply Style to selected geometries. And then we'll select the wall edges from all three parts before we right-click to finish. Next, we'll cut the seams. We'll right-click on the style named Seams, then we'll choose Apply Style to selected geometry, and we'll select all four of the seam geometries before we right-click to finish. The next style to apply is my pencil edge. Same process, right-click, choose Apply Style to selected geometry, select the geometries and finish. And applying the sink style works the same as the rest. Now after applying all these tool paths, we can see where each one will lead in and lead out at the beginning and end of the arrow. We also see that all tool paths are within our blue dotted line working envelope of the table, so we won't get over travel alarms at the machine. Step number 20 is to change any order of operations or order of cuts if needed. This could be done by going to the Operations tab on the Project Manager panel. This shows the order that the machine will run the tools in this program. We won't change the order, and it will remain in the order that we applied the styles and their corresponding tools. We can also view the order in Simulation. If we go to the Simulation tab in our Project Manager, and then we'll click on the Shade Solid Simulation button. You may have to click it twice to see the parts actually as a solid and shaded. I prefer to watch simulation in an isometric view, so I'll click in the display area and then I'll press the V key on my keyboard. Then I'll press the play button to watch my program run, and I can use this slide to adjust the speed. You can also click and drag on the screen to rotate your view if you wish, and you can use your scroll wheel to zoom in and out. And you can still press Z on your keyboard to zoom all, and you can press V to change back to a top view. And the best way to close out a simulation is to click on the icon of the extra toolbar that was put in the top right corner of your screen. Step 22 is to simply save the drawing again. Go to Save and overwrite the existing one. And step 23 is to send the G-code from the icon on the Titan tab. And you can add job notes if you wish. When you click OK, it will start to produce the job sheet. And when it opens, you can choose to print it or view the information, the approximate processing time, a layout of the parts, and a barcode to scan the program into the controller if you wish, and also all the tools that will need to be set up at the machine. And if you had extra parts, go back, open the file, and repeat the process to make the second program. Thank you for choosing Park Industries.